A transversal is going to be, it's a line that intersects at least two other lines in the same plane, okay? So here we have, here's two lines, and then this blue line that intersects both of those is called a transversal, okay? And so we're going to be talking about different angle relationships that are formed when you have that transversal. And then specifically, we'll also talk about what happens when you have parallel lines that are crossed by a transversal. So first of all, we're going to talk about what we call corresponding angles. So corresponding angles are angles that can slide to to a matching angle along the transversal. So for one example here is I have angles 3 and angle 7. So if I take angle 7, if I slide it down, it's going to match up with where angle 3 is on this intersection, okay? So angle 7 and angle 3 would be what we call corresponding angles. They match up. Other corresponding angles would be 6 and 2, 5 and 1, and 8 and 4. Okay, so they can slide down to get that. We have vertical angles. Vertical angles is actually something we're reviewing. All right, so we talked about vertical angles earlier on. Vertical angles are angles that are directly across from each other. So you kind of see, I did some color coding here. So this little light blue, this angle, angle 7, would be vertical with angle 5. And when we have vertical angles, we know that they are congruent. Alternate interior angles. Interior means inside the inside the lines, and then alternate means like opposite sides of the transversal. So our alternate interior angles here would be angle 5 and angle 3. And then also we have another set, we have angle 2 and angle 8 would be alternate interior angles. Alternate exterior angles. Exterior means outside the lines that are crossed by the transversal. And then alternate meaning opposite sides of the transversal. So examples here would be like 4 and 6 would be alternate exterior. So they're outside the lines and they're on opposite sides of the transversal. 1 and 7 would also be alternate exterior angles. Same side interior angles. Interior again meaning inside the lines. Same side means same side of the transversal. So 2 and 5 would be same side interior. 3 and 8 are same side interior. And same side exterior angles. Same side of the transversal but outside the lines for exterior. 1 and 6, 4 and 7. So what we're going to look when we have transversals and parallel lines specifically, there's all these different angle relationships are able to help us solve for missing angles. So first of all here we're going to say that M is parallel to N. These little arrows here are going to be, that's a little symbol that we use to show that M is parallel to N. This is another way or another way that you might see that written. This says M is parallel. We have these two parallel lines to N. So since M is parallel to N, we really only have two different angle measures within this entire diagram. So first of all, our transversal is highlighted here in orange. All right. And so what we're going to look at are these different angle relationships and then what that tells us. So when we have alternate interior angles, interior meaning between the two lines, alternate meaning different sides of the transversal, so like 4 and 5, 3 and 6, okay? Because M and N are parallel lines, those alternate interior angles are now congruent. So you can see we wrote angle 3 is congruent to angle 6. This is the little symbol for congruent. Angle 4 is congruent to angle 5. We also have a relationship that exists with our alternate exterior angles. So alternate meaning opposite sides of the transversal, exterior meaning outside the lines, okay? And so angle 2 is going to be congruent with angle 7. Angle 1 is congruent with angle 8. So if you know two angles, if you have two parallel lines and you know angles are alternate exterior angles, you now know that they are congruent. All of our corresponding angles are also congruent. So angle 1 can slide and match up with angle 5. Angle 2 would slide and match with angle 6. Angle 3 can slide and match with angle 7. Angle 4 can slide and match with angle 8. Those are all different corresponding angles, and now those angles are all also congruent. When we look at our same side interior and same side exterior, those angles are going to be supplementary. So 3 and 5 are supplementary angles, which means that they add up to 180 degrees. And same thing with our same side exterior angles are also going to be supplementary. And then because of linear pairs and vertical angles, all of our acute angles in this diagram are going to be congruent, and all of our obtuse angles will be congruent. And then we can also say that the converse or opposite is also true. So if each of these statements is true, then that tells us the lines are parallel. So we're going to look at a couple of examples here. If I'm looking for a relationship with angle 1 and angle 8, all right, they are on here's my transversal, so they're on opposite sides of the transversal and they're outside of those lines, and so that would make them alternate exterior angles. Angle 3 and angle 7, those can slide and match up in the same position, so those will be corresponding. Angle 5 and angle 8 are across from each other, so we call those vertical angles. Now when we get to solving for a missing angle measurement, we can use, that's where we're going to start using these different relationships. So here I know that this angle is 75 degrees. And so I can use, and these arrows tell me these two lines are parallel. So now I can start using my angle relationships to help me solve for all of these other angles, okay? So one thing I notice is that 75 degrees is vertical to this angle, which tells me that that angle will be 75 degrees. I can also now say that my 75-degree angle, my original angle, corresponds to this angle down here, so that would tell me that's 75 degrees. And this angle up here corresponds to this angle down here, so that means that has to be 75 degrees. I know I have a linear pair here, which means that those two angles have to add up to 180. So now that tells me this is 105 degrees, which now I can say that corresponds down here. That's vertical here, and again, it corresponds here. You could also look for, like you could say this angle up here, the 75 degrees, it was an alternate exterior with this angle, which tells you that those will be congruent because of these parallel lines. So you have a variety of ways to be able to solve for a missing angle measurement, but you're using those relationships to help you. Same thing over here. We have some different angle relationships. We have 3 parallel lines. All these 3 are all parallel. You can tell from these little arrows here. And then that means that this is our transversal. So now we're going to use different angle relationships to help us solve. So I see this 36 degrees is vertical to this angle, so that tells me that will be 36 degrees. I could say that corresponds to this angle, so it could slide down and be in the same position. And we could also do that one more time over here. I can then either use vertical relationships or alternate exterior, even alternate interior. So like I could say this angle is an alternate interior with that angle. But there's a variety of angle relationships we can use to figure out that all of those listed angles are going to be 36 degrees. And then now to figure out what my other angles are, we're going to use what we know about linear pairs and supplementary angles. So for example, within my parallel lines, my same side interior angles should be supplementary, which means that 36 and something add up to 180. And so then I can do that and get 144 degrees. And again, we can use a variety of different relationships. I can say those two angles correspond. This one is vertical. But we're using those different relationships to figure out and solve for different angle measures. All right, have a great day.